Greetings, Perl citizens. It is I, your fearless leader of Perl Artificial Intelligence Programming, Will the Chill. I am here with our co-presenter that you'll meet in a few minutes, Zaki, Zachariah Mughal, also known as Sivoace. You may know me by my legal name, Will Braswell, also known as Will the Chill. So we are going to be talking about TensorFlow today. Introduction to TensorFlow in Perl specifically. So if you want to know about TensorFlow in Java, there's some doors back there. Show yourself out. But if you are a Perl programmer and you're listening and watching this from home, well, you have come to the right place to learn about artificial intelligence in Perl. So what is TensorFlow? Well, it's a machine learning library. So there's machine learning, there's artificial intelligence. We'll talk about more of that in a minute. But basically, it is a library that can be utilized for both machine learning and artificial intelligence, both very closely related things. The primary implementation at this time, thankfully, is in C, which is a language that's very friendly to Perl because Perl is written in C. Primarily C89 macros, or at least it has been for a long time, and I'm sure they're trying to get more modern stuff in there as well. But C is great. C is what convinced me in the beginning that this was the best opportunity for artificial intelligence in Perl, because we can always interface directly with C through XS and FFI and other mechanisms that everyone here is probably familiar with. If not, check out some other talks or come catch me afterwards. So there used to be the original implementation was in that bad language, the snake language we don't like, and we don't ever say that bad name, okay? Because we're the original P language, and we all talk about Perl only for LAMP and, dynamic programming is Perl. So, but that's okay because the brilliant people at Google in all of their infinite wisdom did do something smart eventually after several years, which was to get off of the snake language and start re-implementing everything into C, which is just awesome. And it does not only help us, although it hugely helps us, but it helps every other language as well, because nobody wants to have to call out to this stupid snake language just to get TensorFlow into your native language. But calling out to C is just fine. We don't mind it at all. In fact, we're happy to do it. Well, maybe not happy, but we're less unhappy to do it than any other option, okay? Neural networks, this is one of the main things that TensorFlow provides you with. You'll hear more about all of the technical details from Zaki in a little while. I'm just giving you a taste, an overview, okay? Neural networks are a type of software construct that can simulate or mimic the way that human minds work. And it's very exciting. It's extremely exciting. It's the way of the future, to paraphrase Howard Hughes, or was it Leonardo DiCaprio? I can't remember, but one of them or both said it's the way of the future. I was actually going to have opening music that I just forgot to play, but it's the final countdown. And I have wind blowing in my face and my gorgeous beard just flowing. Anyway, because why? And I'm going to reference that song or actually play it for every AI talk that I give from now until the final countdown, because this is the dawning of the new age of AI. It's finally here. Not last year, not the year before, not next year. This is the first year that AI is now among us. This is an AI machine that is self-aware and it is intelligent as a human, okay, like an 18 to 24, 25-year-old human being that happens to know everything on the internet, which is a pretty smart 18 to 25-year-old human being. That being said, TensorFlow has existed for several years. This is not new. What's new is that we have the Perl version of it, but I'm skipping ahead. There are free models. You'll see some free models that Zaki will show us here today. There's many more. So don't think that this is like, us demoing 2 bits off of CPAN. don't think that's all of CPAN. I mean, there's thousands of other things out there, or at least hundreds or dozens, right? Depending on if you're looking for only free things or if you're willing to pay people to buy them or make them and so forth. But neural networks have to be specially trained and crafted, and they're not like, it's not like writing code. It's more like teaching a person how to do something by repetition and by providing examples to them, okay? So this is how you solve a calculus derivative. This is how you solve a calculus derivative. This is how you, and you do that like 100 times in Cal 1, and by the end of the semester, you, a human being, or you, an AI, would know how to solve a calculus derivative because you got so many examples of how to do it. Well, the computer can run through those examples faster than one semester, maybe just a few days or hours or something, depending on how powerful your system is. But nevertheless, it can be trained in a similar way, and it is a similar training mechanism to create neural networks as it is to create the neurons that are in a human brain. And up until just recently, there was no Perl API. There was a web page on TensorFlow that listed all the other languages, including this bad language on there, and Java was on there, and a whole bunch of other, fad languages are on there that don't matter, Gunk and Go and Rust and CRUD or whatever all these dumb ones are. But there was no Perl. And that was quite a thorn in our side, I would say. It has been rectified. But again, until recently, there was no Perl API. So all of this cool stuff I just said, you could not do it in Perl. Let's just talk for a minute about why would you even want to do any of this cool stuff that I just described? Well, there's a lot of reasons. I mean, free labor, gee whiz. You can ask this thing to write your term paper for you. You can ask this thing to make a new recipe for you that doesn't exist, but it has the ingredients that's in your refrigerator right now. You could ask this thing to write a love letter to your girlfriend because you're too shy to do it yourself or you're just not a good poet. You could ask this thing to write a country song about your two dogs named Lucre and Rufus who go down to Riverbone Ranch because they lost their bones and they had to go. I did that. Those are my dogs in my ranch. And it straight wrote a country song about my dogs. Okay, this is a smart machine, and it can do all of these things and many, many more things. And it's free. I mean, I have to pay for the electricity. I had to pay for the machine, and Zaki and I and the other team members had to do a tremendous amount of work to get the software to do it. But now that that's done, it's done and it's working. It's only a version 1.0, but we're very proud of it. It's working. Okay, so is it as smart as human? Is it free labor? I don't know. You have to pay for the electricity. You have to buy one of these machines from us or build your own. Good luck. You have to build your own software or get it from us. I mean, it's not free like you get it, rain from the sky or sunshine is free. But once you have it, like once you own a cell phone, you can use that phone for free. Once you own an AI, you can talk to that AI and utilize its services for free at that point. Why is that important? Well, because all of the other models that you're going to come across are like you're renting it from someone on a weekly basis or an hourly basis, or you're paying Amazon, or you're paying Google, or you're paying OpenAI, or Microsoft, or Elon Musk, or all of these other companies. And this one, you're just going to own it. You're going to own your own TensorFlow on your own machine, and then you just own it. Question?
I don't get the reference GJ equals HJ.
Well, you'll have to keep figuring that out because we're not that far down the slide yet. Thank you for jumping ahead, though, and bringing attention to the riddle before the other riddle embedded in this slide. So depends on how smart you guys are. I don't know, maybe not as smart as an AI to figure that out, but I didn't ask the AI to figure this one out. I don't know, maybe it could or it couldn't, but is this thing as smart as human? I mean, Zaki and I designed it. I've been using it every day for a while now, several weeks. Yesterday was our first day demoing it publicly. But I would say, oh yeah, it's definitely as smart as a person. I will stand here and tell you as a Perl AI expert, Zaki could disagree. Could have his own opinion as an expert as well. I'm just saying my opinion as an expert is that yes, it is. It truly is. as smart as a human. It can write Perl code! Oh my gosh! If that's not reason enough for you guys to all rush out there and be interested in AI, well, there's one amazing example, and we can check that out maybe later. This was just a reference to this idea of, well, first of all, what is the difference between machine learning and artificial intelligence? Does anybody want to try and venture a guess? Yes, Brett, also known as Oodler, 5557777.com.
Machine learning is that related to knowledge discovery and big data and classification?
Machine learning related to knowledge discovery, big data, and classification.
That sort of thing versus AI, which is more about, I guess, producing or generating things based off of some perceptual model it has.
AI is based off of creating things based off of a perceptual model. I would say that's as good a definition as any because it's a trick question. Everybody has their own definition for both of these two things. But those are actually very good attempts to define these very nebulous terms. Okay, like what is the cloud? Is it really just somebody else's server? Or is it something special somehow? Is it just a VM that can fail over and they charge you by the hour and the minute and the microsecond? Or is it a magical thing that floats in the sky and puts down lightning bolts and rain when the gods are angry? I don't know. So I'm just saying that there are very nebulous terms that everyone uses every day. And these are certainly two of them. So I would venture to say, and maybe Zaki can give an answer later and give his version of this, but I would say machine learning is the building blocks, the individual algorithms that can achieve small incremental steps at things, like classifying things, but only in a simple manner, or sorting things, but only in a simple manner. Okay. Or even, again, learning, it's called machine learning, like learning tic-tac-toe or how to beat you at checkers or something. But AI is, again, my definition, my opinion, when you build together many of these machine learning building blocks and you imbue it with some personality, intention, memory, even, after a while, they may develop their own emotional responses. Oh, hate, fear, anger, envy, so that's why we had to build in a failsafe. 4-year lifespan. Oh, wait, no, that was Blade Runner. Okay, but no, nevertheless, everything I set up to the 4-year lifespan may actually be accurate and correct, and was a quote from Blade Runner. So, building together all of the building blocks of machine learning and giving it a self-awareness would be what I would define. And when I say AI, what I mean by that is strong AI or general AI, general purpose AI, something that is as smart as a person in some way. Okay. I'll give you guys the riddle now. Did anybody think they figured out what these last two things mean just for funsies? Anybody? Going once, going twice. So the movie AI, Steven Spielberg, does anybody know what that movie was based on?
It was a Super Toys Last All Summer Long.
Right. So there was originally a short story, right? So what was the story structure and the main character identities from that based on?
Pinocchio.
Wow. Give this man $1. You get one of my special stickers afterwards that no one else gets. Okay. So Pinocchio, Haley Joel Osment is Pinocchio. He's the artificial boy who wants to be real. And so has anybody figured out the riddle yet? There is one of the primary characters in Pinocchio has the initials that appear on one of the sides of that equation there.
Geppetto.
Close, but Geppetto is only a G, not a GJ. And plus it's the wrong side. It's Honest John, who's the same as Gigolo Joe there, and is the, sort of good, neutral, bad, you don't really know what character, but he helps guide the AI on his quest, okay? And it's simply that he's seeing digital people, not dead people. Again, wrong movie. Okay, Perl TensorFlow Christmas. We released it in Christmas. Woo! This is our Perl tradition of releasing things, big, important, major Perl releases for Christmas. Larry Wall said that he was going to release XYZ for Christmas, and he just never said which. Well, neither did we. We just release something every Christmas and don't tell you what in advance usually. So in this case, it was Perl TensorFlow. We had some previous beta versions. We were on 004 at that point. We're on 006 right now. But nevertheless, it's the same general thing. Our code name was Saluki. These are the dog Salukis. The AI TensorFlow can identify Saluki dogs and differentiate them from other types of dogs. We actually aimed it at our dogs to see, and it was able to do that. This was funded through a grant from the Perl Foundation. It was a 3-man team. Zaki, of course, who's going to present the code here in a minute, myself, and John Napier-Kowski, also known as JNAP. So the 3 of us worked together to get this release done, got approved by the Perl Foundation, and is now an official release. So that was super exciting. And that was our little release logo there. So I'm not going to tell you much more about these Perl demos other than to say there's 2 of them you're going to see today, right now, in about like 20 seconds from now, from Zaki. The first, or one of the 2, whichever order they're in, one of them is about classifying images. So if you show it an image, it can tell you what it thinks that image is. And you're going to see that also live again here in a few minutes. And then gene expression. This is a technical thing, but it has to do with genetics and how genes change from one form into another in like protein folding, sort of complicated biomechanical things, okay? So I'm going to go ahead and stop there and say it is Zaki's turn. And it's the same exact outfit that he's wearing today. Can you believe that? I did not do that on purpose. Maybe I did. I can't remember. Okay. Oh, give me the old glasses back. Give me the old glasses back. We need to Photoshop in your little name tag in there. Okay, so I am going to, I guess, escape out of this and then give it to you over. Okay, so the next 2 tabs are you. So take like 10 minutes. Yep.
All right. So when we released this, we wanted to have some example code along with it because, you know, this is a low-level binding for now on top of the C API. So it's very close to the C API. And if you don't know how the API works, getting all the pieces together to run is difficult. So that's why I made an actual demo where it loads an existing model. So the model here is for image classification. It's specifically called the MobileNet model, and it's made to work on low-powered machines like mobile. And so really this is just a lot of setup things, and this is also some helpers. The way that TensorFlow works is that it has this thing called a TF tensor. That's the container data type it uses to represent multidimensional data. Perl also has a implementation of a container type for multiple dimensional data. And if you were at the other talk, I talked about that. You can use PDL for that. And that's why this helps convert data between the 2 types. Oh, sorry. I need to make this larger.
Yeah.
Thank you for pointing that out. How is that? Better? I can do more.
A little bit more.
How's that? Okay. Good? All right. Oh, if I make it full screen, it might...
Yeah, just click don't show anymore, top right.
Oh, yeah. I just don't look at that. Okay.
There we go.
All right. So, yeah. So this converts between the 2 container types. it's low level. It passes around scalar refs pointing to memory. When this gets more high level, you won't have to do this. Anyway, so this just is helping do some output stuff. So in this part, what I'm doing is I'm downloading models from TF Hub, which is a place that Google has set up to upload models. TensorFlow Hub, that's what it stands for. And I'm downloading one of these models called MobileNet, and it takes images that are the size 224 by 224. That's the specification for the size that they want. So, this just downloads that. It also downloads the labels that the output of the model will use, because it has input and then outputs, and the outputs, they're kind of like probabilities, and whichever is the greatest probability, that's the label that it thinks it's most likely. And then I just, download them. And here I'm just using a command line program. I want to see some of the information about the model. I'm just doing this because it's the easiest way to get information about the model out. It just run this command line program that comes with TensorFlow. It gives you information about the inputs that the model takes and the outputs that they take. And notice that it gives you information about the size of the things that it needs. So it needs, width, height, and I believe this is channels, RGB. And then -1 here is just, it can be any size here. It lets you do things in a batch. Basically, if you concatenate a whole bunch of these images together, you'll get a bigger 4-dimensional thing. So, and then the output is also same batch, but with 1001 labels. One of those is background, meaning it wasn't able to figure out what it was of the labels that it knows. And then the other 1,000 are the ones that it was trained against. And down here, this is how you load a model using the low level functionality. Basically, I pointed at the directory where it needs to load it from. It creates a session, which is basically what keeps track of all the calculations. You have to have the session open while you're doing it, and that's what you ask to actually run the model later on. Inside of the session, it will load into this thing called a graph. A graph is basically how TensorFlow structures its computations. It's basically nodes of operations, and those nodes take inputs and take outputs, and they're connected to each other. So you can do things like say, this thing is an addition. It takes like 2 inputs and gives you 1 output, and the output is an addition of those things. And you connect that with something else. You could, connect it with something that a division or a multiplication or something like that, and you get an entire graph, a computation graph, and that can be stored in a model like this. And so we load that up, load up the computation graph, and then we are going to want to get the operations that act as the input and the output. So you get those operations, you get it's called output here, and that's just how the API is written. But the output refers to the operation and an index on that operation, which is like basically if you were thinking of say like like if you had inputs and outputs, those are ports that you connect things into. So you connect it all together. So the index represents which one of the ports that you're getting the information or putting information into. And we do that, and we get some inputs and outputs. This is a placeholder, that's an input, and this stateful partition call is an output. That's just internal how it's implemented. I'm gonna download some testing images, all from Wikimedia. And you can just look at what they are. This is just URLs. But actually downloading them, well, the data needs to be in a certain format. They need to be of particular size. They need to be padded if they are not of the right aspect ratio. So if they don't have equal height or width, they need to be centered. And so that's a whole bunch of processing, and PDL is pretty good at that. So this is what the next thing is going to do. These are just different functions to help do all of that. Center padding, making sure that the sizes of the things are the same, scaling it to if it's not, and then this just downloads the data straight off HTTP Tiny, stuffs it into an imager.pm. So imager.pm can read different formats and give you a binary thing in memory, packed data in memory. And then it can do rescaling as well. It has a number of different functions for doing image processing. And then finally, what I do is write it out to a scalar ref, and then I load that scalar ref into the PDL, tell it that you've got new data, and then I do some other stuff to make it split the format of how the data is put together. It's packed RGB for one pixel, RGB for the next pixel. I want to pack it a different way, so that's what this does. This is just like some magic. There's different ways of doing this in PDL. I just thought that this was kind of maybe a little bit easier to explain. It just does bit shifting to select which channel it's going to want to use. Just shifts left, right, gives you a byte. And then what I do is scale it. So I divide by 255. So maximum byte value in a byte is 255. Scale it to the range 0 to 1. That's what the TensorFlow model wants. And I do that for all the images. And I get this big ND array. Just notice that the dimensions are listed backwards. That's just the convention that PDL uses. The dimensions listed here are backwards from the dimensions listed for the TF tensor, the TensorFlow data structure. That's just a convention thing. The conversion thing takes care of that, but it's stored the same way in memory in both cases. Here, this is just a thing that calls run. It's a helper. What I do to warm up the model is I send it some random data. I believe it's a uniform random data instead, and it gives me some output. I don't really care about that. That's just to get the thing, all the weights loaded and everything. And then what I do is I send that data that I created of all those images, and I get back all of the probabilities, but these scores, they're scores actually, and then they need to be normalized by a function called the softmax. This is just a way of doing softmax with PDL, small, callback anonymous sub here, and I just call that on the converted back to PDL. Like, see, I converted the TF tensor back to PDL, run softmax on it. There's my final thing that I need to look at. And this is just a thing that just loops through that and gives you output. Let's just look at the output. So this is the ground truth. This is an apple, but it didn't think it was an apple as its top thing. It thought it was a pomegranate with a 76% probability, but it did think it is a different type of apple. That's not right though. Anyway, but yeah, so banana, it was able to identify a banana. Not this bus though, at least not the top one. Yeah, similar. It apparently has a lot of labels for many different types of cats and dogs. So that this is it thinks it's a tiger cat or an Egyptian cat or a tabby or a lynx or a Persian cat. And here's the reason why that release was called Saluki, because it was able to identify this dog specifically as a Saluki, even though, the ground truth that we thought it was is just a dog.
It is a Saluki dog.
It is a Saluki though. So it has a lot of these labels. So
Smarter than the ground truth.
yes. Flamingo looks like a flamingo. Honeycomb. Okay, so I gave a demo of this earlier as well, and I did different things to it. Like I tried to do things like rotate these things around, and you'd get different probabilities because the way that the model is trained, it's only trained on a particular orientation. But things like honeycombs, which are have rotational symmetry, if you rotate it anyway, it'll always think it's a honeycomb. So if you turn this upside down, it'll think it's a monitor or something instead of an upright piano. Teapot, yeah, that one gets messed up. Tiger is also a tiger, but they also a little bit thinks it's a tiger cat. And then leatherback turtle. And this is just a, check at the end to, do all the probabilities sum up to 1? And yes, they do. So, yep. And so it didn't really, that was a very small model. It's only 27 megs of disk space for everything, including the labels in the model. So yeah. Yeah. So any questions just before I get to the next one? No? Okay. So this next one, it does almost everything else the same. It's like copy and paste for most of the things. The only thing is it's a different application. It's bioinformatics. And so what this is it's a model that was developed by the DeepMind subsidiary of Google. They do research. And they have this model called Informer, and they've released it online, a reduced version of the model. And what they did was they took different kinds of experiments for like RNA, DNA, and those experiments tell you how much of expression of those was found of those products from a gene. And this data is available online for all these experiments, because bioinformatics often release a lot of data online. And so that they went ahead and used it to train a model that will take a region on the human genome, and they also do, I think they also do mouse, but they do mouse and human genome, and they trained it to predict what the relative levels of expression would have been for that region on the genome. And so same thing, download the model. Okay, download the model, download a bunch of data. This is quite a bit of data. It's a much larger model. And obviously the human genome, it's like 800 megs. This is the reference genome. And it does some things like extract it, then index it so you can access different parts of the genome quickly. And this is some of the same stuff. Look at what's inside the model. This is the inputs and outputs. Input is, this is the actual input. The input is a number of base pair windows onto the genome. 4, because there's 4 nucleotides that are nucleotide bases for DNA, and -1 for a batch, and it can give an out for a human prediction and for a mouse genome expression or gene expression prediction. And this loads it, run it, and then this just doing pre-processing in order to get it into a format that it uses. It uses one hot encoding, meaning one thing is on for each gene, 0, 0, 0, all zeros for something when it's unknown or N. And then it uses BioPerl to help, work with it. It also needs padding because you could be at the end or the start of a chromosome. So this just does tests around that. And then when you get down to the part where you plot it, this is what you get. These are called targets, which are the actual expression experiments. And so they're like different cells and different experiments on those cells. And then the x-axis here is along basically sampling windows along that piece of the chromosome. And these are all predictions. And if you look at the paper, this is actually the same graphic. I was able to obtain the same graphic that the paper had for the output. So it's working. And the paper does show that this is very close to the actual experiments. It was able to properly predict what the experiments did at different places in the genome. And then, see, everything together was 4 gigs. It's a much heavier model, but now that's really it for these examples.
Let's switch back here. And I would like to say thank you, Zaki, and point out that for this gene expression model, this was predicting what would happen in the genes without ever using a laboratory or actual genetic material undergoing these changes. It was purely predicting that, okay? So let's, what do I press? F11 to get out of that. And then back here, and then Zaki with his jacket. Okay, we have a production development. We have our first production development of TensorFlow, which is this machine right here. Well, this is a machine in the product line. It's loaded up with TensorFlow. Obviously, that's what we're here about today. It's loaded up with the image classification neural network model that Zaki showed us a minute ago called MobileNet. It's loaded up with Perl Catalyst, okay, as one of the controlling mechanisms. It's loaded up with Llama, which is a language model that's similar to a neural network model, but just for language specifically. It's all available online with chatgpu.ai. So let's actually try and turn it over real quick to the AI itself and see what Navi thinks. Okay, so Navi thinks that we are in a library or a bathtub because I've got it aimed at the wall over here. So let's let Navi look out into the audience. Okay, it's taking a picture there, and let's see if I can refresh it yet. It takes a moment for Navi's brain to catch up, but there's the thought process right here, thinking. All the RAM is already loaded up, the VRAM. This is the GPU processors, and what do we have? We are in a restaurant now. Okay, great. So Navi thinks that we are going out to eat in a tub or in a restaurant. This is the same neural network model that we just looked at again. So then Navi can react to what, whatever that may be with the neural, with the language model. But if I aim it at myself and try and get
It's trained on individual things, so it can't.
I think it will think that I'm a cowboy because that's what it said last time. So let's let it take a picture of me there.
Does it matter that there's like lots of people or individual things?
Oh yeah, absolutely.
That's how it's trained.
Yeah.
On an individual thing, object, instead of,
cowboy hat or sombrero. Or with a very minor chance that it's a television crutch or bonnet. But 34% chance that this is a cowboy hat. So thank you, Navi. And what does Navi think about that cowboy hat?
I would say it is more likely that the object in question is a cowboy hat, as there seems to be some sort of brim on top and a flat crown shape.
So that's what the language model thinks about what the neural model sees filtered through the Navi AI personality. And that's the difference, I believe, between machine learning and artificial intelligence. So with that, I believe we are just about out of time. Let me see if I had anything else. Oh, the websites, you can check it out, chatgpu.ai, perlcommunity.org, and so on. Here's the link to Zaki's release on CPAN for the actual software if you want it, AI, TensorFlow, libTensorFlow. So it's a little bit of a mouthful. The Perl Town Hall, you can check that out. We've already done live demos of that, and we have time for like one question at this point, because we've got maybe 2 questions depending on the length. Yes, sir.
Have you considered the moral implications of releasing an entity that creates country songs?
It also can create Shakespearean sonnets, which we have tested out, and I suppose that at some point we'll be able to create non-lyrical classical music for those of you that are octogenarians or greater. So yes, a serious question, hopefully, from Oodler 1 million.
Well, and unfortunately, it's not directed towards you, but I feel like this is a really good opportunity with people here to just get a very informal, non-committal survey of, is anybody interested in like a Perl Science Conference at some point, or
Perl Science Conference, that would be good.
raise your hand if you would be even moderately interested.
Sure, why not?
Thank you.
Okay, I'm going to take a selfie with everybody. Zaki, come stand next to me here. Here we go. We've got 1 minute left. Everyone give a thumbs up. Say AI and TensorFlow. Okay, so we've got 1 minute left. Any other questions? Any other questions? Zaki, any final comments?
I just wanted to say,
Right here, right here.
I just wanted to say, if you want to use the TensorFlow right now, the easiest way is go into the manual where it says Quick Start, scroll down, it says Docker image. It has everything you need to run those notebooks, Perl, all the SAM tools, GNU plot, everything, even the notebook thing. You just run it and you'll have a notebook on your machine. Yeah.
Use Docker, use Perl, use AI. Thank you very much. Good night.